go. Okay, so good morning. It is Tuesday, September 28th. It's World Rabies Day. Give it up for rabies, everybody. I don't know how you celebrate World Rabies Day. Maybe you go out and get bit by a dog, you know. Hey, there was a vaccine, right? Like we're in the middle of like vaccines. Some people want it, some people don't. But back then, people would die from rabies, like for, like 30, 40 days later. It would be a painful death because they get a stomach ache and then their throat would itch and swell, and they get hydrophobia, which doesn't mean that they're afraid of water, right? It means that they can't even swallow. Their throat, ugh. So it was bad. But then a French guy, a French scientist, the guy who invented or discovered the process of homogenation, right? Which your milk is homogenized, makes it last longer. A French scientist came up with the rabies vaccine. And you used to, like, if you got bit by rabies, they had to give you, like, if you got bit by, not rabies itself, like what would rabies look like? But like if a rabid animal, like a bat or a dog, if you got bit, you would have to get like a series of shots, like into your stomach, like 40 of them. And that's how you kind of got rid of rabies. But anyway, it was better than dying 40 days later, right? Anyway, do y'all know the name of the French scientist who invented the homogenation process and discovered the rabies vaccine? Pasteur. Very good. Yeah. And that's why the homogenation process, I think it's called pasteurization. Pasteurization. It's named after Louis Pasteur. Yeah, very good. Hey, on this day in 1066, speaking of history quiz, one of the most famous battles eventually of all time, 1066, Battle of Hastings, right? That's one of these things to be culturally literate, as I was talking about this E.D. Hirsch book. E.D. Hirsch Jr., I guess his dad was also E.D. Hirsch. My dad, remember, was Wayne, Lil Wayne now. But E.D. Hirsch, right? You got to know certain things to be a citizen of the world. And one of them is 1066, the Battle of Hastings, right? Well, the Battle of Hastings occurred on October 14th, so that's still a little ways away. But on this day in 1066, William of Normandy, not quite yet known as William the Conqueror, William of Normandy, who was the cousin of Edward the Confessor, who was the King of England at the time, he invaded England at Pevensey Bay, Sussex, East Sussex now, and he landed. Well, when Edward the Confessor died, he had no heir, or he did have an heir. I guess his son was the heir, Harold. But William thought that he had a better right to the throne than his cousin's son. So what did they do back in the day? He landed at came from Normandy, landed at Pevensey Bay with 7,000 men, and then marched to Hastings, where like in one day he overthrew his cousin's son, King Harold, and then he marched to London, and at Westminster Abbey he was crowned king, and he was the first Norman king of England, and he ruled for, do your math, he ruled for 20 years until he died. And then his son, William Jr., William II, kind of took over. So anyway, 1066, Battle of Hastings. Y'all have heard of the Battle of Hastings, 1066, right? Now you have, right? 1066. Right? When you're an old person, you'd be like, 1066, Battle of Hastings. You may not remember like who was involved, but it's one of those ones you need to remember. Happy birthday, Confucius, right? Hey, man, that guy said a few wise things. He was born on this day in 551 BC. Like, how do we know? The records were pretty good back then. I mean, how do we know he wasn't born yesterday? Someone kept good records on this day. Hillary Duff turns 34 today, right? Hillary Duff, y'all know who that is, right? She's actually from, I think, the Bernie area. She was like she's like a hometown girl almost. And then one of my favorite rappers that I have no idea who it is, Jeezy, right? Hey, Jeezy turns 43 today. Anyone listening to Jeezy out there? Not Jesus, Jeezy, right? Yeah, Jeezy. Okay, the word of the day is perfidy. Perfidy, that's a pretty good word. Perfidy is a noun, and it's a deliberate breach of faith or a violation of trust. What they used to call treachery back in the day, treason, right? Your friend can commit an act of perfidy, right? When they tell everybody that you're a Hillary Duff fan or a Jeezy fan, right? They're like, oh, like back in the day, Michael Jackson was huge, but you didn't want to tell anybody you were a Michael Jackson fan. You had to kind of fly under the radar. But if your friend tells people, that's an act of perfidy. Perfidy, yeah, it's a good word, perfidy. Notice the root in perfidy is FID, FID. FID is the Latin root for fidelity, faithful, right? Faithful, like semper fidelis. That's the Marine Corps model, always faithful. Some people have a dog and they name him Fido. Fido comes from fidelity. So like that dog, hopefully would grow up to be a faithful dog. That would suck if you name your baby dog, your puppy Fido, and then it grows up to commit acts of perfidy left and right. Like, dang, I should have named you Perfidy or Perfido instead of Fido, right? Anyway, there's my little introduction for the day, right? Now let's go over the warm-up. When's y'all's test? Thursday, okay? And again, I did put the grades for the retest into the grade book this morning. All right, so finding the domain, we're trying to avoid division by 0. We're trying to avoid square roots of a negative. So if you look at this function f of x, does the numerator concern us at all in this case when it comes to finding the domain? No, okay? In this case, the only time the numerator is going to affect the domain is if it has a square root in it, right? It will affect the function, right? It will affect the zeros, but right now we have a radical in the bottom and it's under a square root. So number one, we're going to say 2 minus 7x has to be greater than or equal to 0. And number two, the entire denominator, radical 2 minus 7x cannot be 0. So if you set that up, right, sock, sock, now we can do shoe, shoe. This is a linear inequality, so we can solve it. Remember to flip the inequality. The other way to do it is if you ever have a negative linear term, instead of leaving it on the left and possibly forgetting to flip the inequality, just bring it over to the right. Now, if you're going to show the division by 7 on both sides, show it like that. And now you get this 2/7. And now you flip it around. The alligator is eating the 2/7. And so now it's still eating the 2/7. So that's another way to do it if you think you might forget to flip the inequality when you divide by a negative. Now, we quickly check, don't we? We quickly check. We're saying that those values work, which means they give us a positive under the radical. So something smaller than 2/7, like 0, should work. 2 minus 0 is positive 2. That's good. And then something that's not less than 2/7, like 1. 2 minus 7 is negative 5. That's negative. It doesn't work. Good. So pretty confident that's right. Now over here, we have a radical function. And remember, when you have a radical function, in general, you need to be careful, right? It either rings a little bell in the back of your head, right? Or it raises a red flag. And of course, ringing the bell is safe now. You can do it because you need to check for extraneous solutions. So when I square both sides, I'm not going to show that here, but I did yesterday, okay, just because we were talking about it for the first time. But you square both sides and you get this, and then you end up with x cannot equal 2/7. And now we check. Here's how we check the extraneous solutions. Does it actually cause a 0? You just plug it right back in up here. Does it actually cause a 0? 2/7 times 7 is 2. 2 minus 2 is 0. The square root of 0 is in fact 0. So yes, it does cause a 0. It is not extraneous. Now remember, in this case, we want to combine our results in the correct way. We don't want to doubly exclude anything. So on the one hand, we're saying x has to be less than or equal to 2/7. But over here, we're saying it can't be 2/7. So as I mentioned yesterday, we don't say, I like peas and carrots, but I hate carrots, right? You don't even need to mention the carrots. So all we have to do is combine the results, and we say d sub f colon set of all x such that x is what? Less than, strictly less than 2/7. There you go. Or if you're the interval type of person, is 2/7 an upper bound or a lower bound? Upper bound, good. So negative infinity all the way up to 2/7 with a wimpy parenthesis, x epsilon, right? There you go. It's fun, it's easy, it's fun easy. It's darn near fun easy. Okay. All right. Any questions on that? Yeah. Yes, you could do that on the test, right? If you know what you're doing and you want to set it up as 2 minus 7x is strictly greater than 0, and then you get down to x is strictly less than 2/7, because you know that normally the radicand has to be greater than or equal to 0, but in this specific case, it would leave you with the 0 in the bottom, so you take away that value, you would get 2 checks for this setup, which would be equivalent to getting 1 apiece for here. Okay? Yeah, so that's fine. Any other questions? All right. Well, let's move on then. Remember, we're only testing through example 7. That was your question, huh, Luke?
Well, I was going to ask.
Okay.
If there's like a specific form you would have us put it in.
Like in the end?
Yeah.
No. Like on a free response, I will say in the instructions, put your answer in set or interval notation. So I'm always doing both, but I would only expect to see one of these. I'm not going to like force you, hey, use set notation here, use interval notation there. But on a multiple choice question, when I put answer choices, I may put them in set notation. I may put them in interval notation. So you should at least be able to decipher both of them. But in terms of writing your final answer, you just pick one. Yeah. Sorry, I anticipated the wrong question. Yeah, good. Any other questions? I'll let you ask them this time. Okay. So we're only testing through example 7, remember? So we are on example of 5D. 5D. All right, so again, we're finding the domain, trying to avoid division by 0, trying to avoid square roots of a negative. The numerator is no concern to us because it doesn't have a radical, but there is a variable in the denominator and it is under a square root. So I'm going to give this function a name. I'm going to call it j of x for gz of x. Happy birthday, gz. All right. So here we go. Maybe at the end we could. I know the radicand, 3 plus 5x squared, has to be greater than or equal to 0. And I know the entire denominator, 3 plus 5x squared square root, cannot equal 0. Sock, sock. Now we do shoe, shoe. Okay? 3 plus 5x squared. Hey, is this a linear inequality? Is this linear? Is this x to the first? No, it's x squared. So if you remember, we've already had this discussion this year. We cannot solve quadratic inequalities algebraically. Okay? You can't. You have to solve them either graphically, which is what I taught you to do, or you set up a number line chart and you do test intervals. Okay? Which some might argue is algebraic, but not really. So I want you at this point to understand how graphs work and what the transformations of the parent function are. So that's how I want you to do it. So let's look over here off to the side. 3 plus 5x squared plus 3. By the way, if this question were on a free response with a quadratic inequality, I would say in the instructions, be sure to show your graph. So that's one of the things I'm looking for. The parent function, of course, is x squared. And x squared, as everybody knows, looks like, let me do it in red, looks like this. It has y-axis symmetry. It bounces at the origin and continues on domain of all real numbers, range greater than or equal to 0. All right, so what does the transformation look like here? Well, what does multiplying in front of the x squared by a 5 do? In this case or any case, if you multiply in front by a 5, it's a vertical stretch by a factor of 5. That's how I write it. VS means vertical stretch, and BFO means by a factor of. So that would be like grabbing the graph on either side of the x-axis and vertically stretching it. All the y values are 5 times bigger. So at the origin where y is 0, 0 times 5 is still 0. Over here where y is 1, it now becomes 5. Over here where it was 2, it's now 10. So you can see that it makes it essentially steeper, right? And then the plus 3, which is outside the x squared, also affects the y values. This is going to be up 3. So if it's outside the squared function, it's affecting y values. You know that as well from algebra 2. If it's inside the squared function, it affects the x values, which is horizontal. So vertical stretch by a factor of 5 and then up 3. Right? And you got to do it in that order because your dear Aunt Sally says you got to do multiplication before addition. So what normally that means is, you know, you could do it from left to right. So I'm going to go ahead and just call this 3. And now I'm just going to draw it a little bit steeper. Okay. And there is the graph of y. That's not the graph of j. What I call j, don't get confused. This little green parabola is not the graph of the original function. That's just the graph of the radicand, okay? And now I return to the inequality. I want to know for what values of x is that graph greater than 0 or equal to 0? Well, remember that means on or above the x-axis. This means on or above the x-axis. So for what values of x is the green parabola above the x-axis? All of them, right? It's above the x-axis everywhere. The closest it gets to the x-axis is at the vertex, which is when x is 0. So what's the solution to this inequality? We'll just say all real numbers. We'll just say, oops. I'm going to move this down a little bit because I did write it in the flow of my project. Okay, there we go. So I'm just going to say x is an element of the real numbers. Okay, you can do it like that. All real numbers. All real numbers. So does that mean there's any restrictions? Are there any restrictions? No. Any value of x is going to work. Now, come over here. Solve this one, right? It's a radical function. When you square both sides, the radical goes away. 0 squared is 0. Now it raises a red flag. Does this have any solutions? Is 3 plus 5x squared ever 0? No. The closest it gets to 0, once again, is when x is 0. It's 3. If it were equal to 0, remember that's graphically looking for x-intercepts. And it has done. So 3 plus 5x squared equals 0. This one has no real solutions. So what that means is there's no restrictions. Now, if you wanted to solve it algebraically, here's what it would look like. 5x squared cannot equal -3. X squared cannot equal -3/5. And when you take the square root, you get plus or minus the square root of -3/5. Well, as we said yesterday, the square root of a negative is an imaginary number. So that would be the square root of 3/5 times I. The only thing that gives you a 0 in the denominator are imaginary solutions. And therefore, all the real numbers work. So let's think about what the domain is then. Are we ever going to get a negative under the radical? No. It's always greater than or equal to 0 for all real numbers. Are we ever going to divide by 0 with any real numbers? No. It's always 3 or greater. So are there any restrictions at all to this function? No. So down here, we'll say the domain of J is the set of all x such that x is an element of the real numbers. You could do it like that. Or if you want, we don't see this very often. If you want, you could put d sub j, and then you could just put double bar r. The double bar r is the name that we give to the set of real numbers. So if you want to make the braces, that's how you would do it. If you want to do interval notation, you would say x epsilon, and we would say -infinity to infinity. Okay? There you go. So real quickly, just because there's a variable in the denominator doesn't mean you're going to divide by 0. And just because you have a variable under a square root doesn't mean that you're going to have any negatives there. You actually have to do the math. Here is one where we had the potential of dividing by 0 and taking the square root of a negative because there was a variable there, but they all passed. They all work. No restrictions. Okay. Awesome. Comments, questions on that one? Fun, 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 right? Good stuff. All right, now look at the next three. They're very similar, but a little bit different, okay? They all have the exact same numerator. So we'll kind of do all three of these in one shot. They all have the exact same numerator, but they do have different denominators. Yeah, yeah? So let's go ahead for all three of them and do a one-time deal for the numerator. We know that 5x minus 3 has to be greater than or equal to 0. So that means 5x has to be greater than or equal to 3, and x has to be greater than or equal to 3/5. Now, I know that that's right. I don't recall making a mistake on my way to 3/5, but I'm going to check it anyway. Something bigger than 3/5 that I claim will work, like 1. 5 times 1 is 5 minus 3 is positive 2. That's good. Something not bigger than 3/5 that won't work, like 0. 5 times 0 is 0. 0 minus 3 is negative. Okay? Pretty confident that that's right. So that's going to be a restriction or a demand, if you will, of the numerator for all three of these functions. Now, each of them have a different denominator. So here's part E. We know x squared plus 2x minus 3 cannot be 0. On part F, we know x squared plus 4x plus 3 shall not be 0. And on part G, we know that x squared minus 4x plus 3 shall not be 0. So I'm setting all three of them up at one time. It's like putting on all three of your socks first, right? On all three of your feet. Sock, sock, sock. I'm on eBay a lot. My wife wishes I weren't. I saw one, you could set up filters so that anytime something new comes up, you get an alert. And I follow Hoka, you know, you can get some pretty good used Hoka shoes, size 14 every once in a while. And so one time I went and there was a shoe that was like in really, really nice condition. It was a Hoka One, and the shoe looked like it was brand spanking new. And it was only like $15 with free shipping. And I'm like, yeah. And I almost bought it, but then I was like, well, let me go through the pictures. And as I kept going through the pictures, it was just the same shoe, like from different angles. And I'm like, man, it's in pristine condition, like it's never been worn. And then I said, well, let me read the description before I buy it. You know, sometimes I do that. When all else fails, read. And it turns out that it was a brand new shoe. And it said, sold as is, single shoe, the non-used shoe of an amputee. So I was like, oh, okay. So yeah, if I would have purchased it without reading, I would have expected 2 shoes that were in that pristine condition, but only 1 shoe would have come, and I would have been like, what the? But apparently an amputee had bought a pair of Hokas, and I guess he didn't use it. Maybe he had one of those blade feet for his other one. So anyway, having 3, I've never seen an ad where there's like 3 shoes, right? There's a left shoe and a right shoe and then a middle shoe that's straight and not curved at all for the guy that has like, you know, whatever. Yeah. Anyway, you got to be careful too, because I did see an ad recently. It was a box, and it had Hoka and the style in size 14, and all the angles were of the box. You know, like here's the bottom of the, and you're like, oh, that's a good model of a shoe, right? And it's only $15 again with $5 shipping. Well, if the shoes are in good shape, but then you read the description and it says box only, shoes not included. Like someone's trying to, you know, they do that all the time with like an Xbox 5 or whatever, PlayStation 5. They show you the box and it's real cheap. You're like, man, I'm going to get a steal. And you buy it without reading, and then it's just the box. You're like, caveat emptor. All right. So anyway, I don't know why I got off on that tangent with 3 shoes, but be careful, right? Read. When in doubt, read. Let's go ahead and factor this. This is x plus 3, x minus 1 cannot equal 0. Yeah, I think. Check it. Yep, that looks good. So we know that x can equal -3 and x cannot equal 1. Perfect. All right, let's go to part F. This one factors x plus 3, x plus 1 cannot equal 0. So over here, x can equal -3 and x can equal -1. And then on G, this one factors x minus 3, x minus 1 can equal 0. And so now we get x cannot equal 3 and x cannot equal 1. Remember, once you start your equal sign, you got to keep going. All right, so now as we come through and we put our answers together, combining it from the results of the radicand and the denominator, remember, you don't want to doubly exclude an answer, right? So if you're already omitting something categorically, you don't need to come back and omit it individually. All right, like again, if Mrs. Lincoln's class was going on a field trip and I said, y'all can't go, I'm sorry, it's just Miss Lincoln's class, but I'm going to chaperone, so none of y'all can go, all right? You're already, as a group, I'm not singling anybody out, and you're like, okay, I guess that's fine. But then I say all of a sudden, but Tyler can't go especially, right? And yeah, and Tyler's like, well, why me? I mean, you already said I can't go, I'm part of the class, but why single me out, you know? We don't want to do that. So if there's a value that's already excluded by the inequality, there's no need to come back and exclude it again. So let's go ahead and go through it. On part E, the domain of F is going to be, do your math homework, the set of all x such that x is greater than or equal to 3/5. That's going to be part of it. Now, look at the division by 0 restrictions. Are either one of these guys -3 or +1? Do any of those guys fall on this interval? Or either one of those bigger than 3/5? One of them is. Which one? One. Which one? Yeah, one if one is. One is. Yeah, one. Right. One of these two.
The one that is not -3.
Right, that one, right? Oh, numero. Okay, yeah. So x cannot equal 1. Good. Boom. There it is. All right. And now, if we want to write that in interval notation, that would be, let's see, 3/5 is a lower bound, yes. So x epsilon, beefy bracket 3/5, cruise to 1, step over 1. There you go. Okay. Go ahead and do the next two on your own. Do the next two. I'll do them with you quietly and we'll compare answers. Well, or y'all could just have a high emotional quotient and tell yourself you're not going to look. But yes, Brady, that's not a bad idea. You're going to make a good teacher someday.
This is common sense, though.
Common sense is not so common.
We are trying to get the hard best.
When you're making your beefy brackets, please make sure that they can't possibly be mistaken for parentheses. Okay. In haste, you know, you can round the corners. My brackets aren't, you know, the best unless I'm making the beefy brown bracket, beefy brown. I don't really take the time to exaggerate the curves. Now, with Notability, you can snap little line segments to make them real pointy, but you know, that's kind of takes a little more time. So just make sure that I can tell a bracket from a parenthesis, because if there's doubt, beefy brown, I'm not going to spend the time like asking around, hey, what do you think this is parenthesis or a bracket? Take a picture, put it on Twitter, make a poll. Hey, do you think this is parenthesis or a bracket? I'm just going to say, can't read it, right? Ambiguous, lose points, right? You'll lose points for ambiguity, not necessarily for having a wrong answer. Because what's the goal in this class? Not just to get the right answer, but to communicate it effectively. Right, right. And we do that by thinking all the time, all the time. And we're going to do that because we care, right? And when we care and we think and we persist through the hard times, we develop this trait called sisu. You've probably seen this around. I don't know if anyone's Googled it, but sisu is essentially what Jaime Escalante in the movie Stand and Delivered called ganas. Ganas. And I found a patch on eBay this summer that said ganas auto. It's crazy. And I actually searched ganas patch because I have a hat press machine I can iron on, you know, backing and putting it on the hat. So I put it on this hat, and I think my press was too tight because it made like a little line here. But anyway, I now have a ganas hat, and ganas is the Spanish word for the Finnish word sisu. Okay, it encompasses an entire philosophy. In short, it means desire, persistence, tenacity, but it means so much more. It's kind of like a way of life. Oh! Okay. So, by caring and thinking all the time, persisting through hard times, right? Getting your questions answered, finding a way because you have the will. That's when you develop sisu or ganas, right? Ganas, right? Ganas. That'd be cool. Like some guy has an automotive, like a mechanic named his place Ganas. I like it. If I were a mechanic, maybe I would open my mechanic shop and call it Sisu, right? And then when people picked up the car and they left, I could be like, Sisu later, right? And they'd be like, oh, I hope your mechanic job is better than your puns. Right? Anyway, I do have a patch coming in the mail that says Sisu. So maybe I'll bring my Sisu hat to school. Once I get the patch, put the iron-on backing on, and then press it to my next hat without the press being so tight. We don't want to make that extra crease. All right. So far, so good. We got it. So far, so good. So good so far. All right. Let's go through this one real quickly. Example 6. Find the domain of each of the following. State your answer and set our interval notation. We're trying to avoid division by 0. We're trying to avoid square roots of a negative. That's it right now. Look at this guy right here. Do you see any square roots, any radicals? Yes, but look what's underneath it. It's only a 3. Yeah, is 3 ever negative? No. What if for Halloween 3 goes dressed up as a negative number? Does that make 3 a negative? No, because the clothes don't make the man, right? It's still a positive 3. And the man doesn't make the clothes, right? Do we have a denominator? We do. But is 3 ever 0? No, not even at a masquerade party, right? So if it passes both hurdles, guess what the domain is? It's all real numbers. Yeah, all real numbers all day long. In interval notation, it would be x epsilon negative infinity to infinity. Okay, so again, just because it has a radical square root doesn't mean that it's going to have any restrictions. Just because it has a denominator doesn't mean it's going to have a restriction. All right, letter B. This is called an exponential function. Exponential. Okay, and the reason being is because it has a variable in the exponent instead of the base. Is this ever going to give us a fraction? Sure. Yeah, right. What is g to the negative first? It would be 4 to the negative first minus 5, which we know is the same as 1/4 minus 5, yes? But is 1/4 ever going to be 1 over 0? No, because 4 is not a 0. What if I did g to the negative 100th? That would be 4 to the negative 100th minus 5. That would be the same as 1 over 4 to the positive 100th minus 5. Okay, is 4 to the 100th ever going to be a 0? No, that's actually getting bigger, right?
Well, technically, it's also getting smaller as well.
No, 4 to the 100th is getting bigger. So 1 over 4 to the 100th is getting, well, that's what I was getting at, right? But you got to, yeah, 4 to the 100th is getting bigger, right, Brady?
Yes.
And so it's reciprocal. The fraction as a whole is getting smaller. The reciprocal of a really big number is a really small number. We just got to be careful, right? When we communicate, we don't want to throw the baby out with the bathwater, Brady, do we? We keep the baby. What if I did g to the, what if I did g to the 1/10? That would be 4 to the 1/10 minus 5. That would be the 10th root of 4 minus 5. Right? Now I have a radical, but is that ever going to be a negative under there? No, it's always going to be a 4, right? So if the bottom is always going to be a power of 4, which is never 0, right? 4 to any number is never 0. And I can generate radicals with fractional x values, but it's never going to be a negative under there because it's always a 4. I pass both hurdles. Guess what the domain of G is? All real numbers. Yeah, all day long. So when we study exponentials again later in the year, we're going to use E as our base. E the number, not E the letter. And one of the traits or characteristics of exponential functions, Ed, is that they have domains of all real numbers all day long. Okay. Finally, the last one, h of t. I do have a denominator, but there's no 0 in it, right? I have a square root, but it's a 3 underneath it, which is not a negative. Now, I do have a variable in the top, but it's underneath a cube root. Am I allowed to have a 0 under a cube root? In other words, can t equal 1? 1 minus 1 would be 0. The cube root of 0 is 0. Right, that works. If this were in the denominator, now we'd have a problem, right? Because we still can't divide by 0. But our denominator is never 0. Now the question is, if t is something like negative 1, negative 1 minus 1 is negative 2. Can I take the cube root of a negative number? Is that okay? Yes. Negatives under a cube root or an odd root are okay, right? This is an odd root. Negatives under the radicals are okay. They're fine, right? The cube root of negative 8 is equal to negative 2. In fact, the cube root of a negative number will be a negative number. The odd root of a negative number will be a negative number. So be mindful of that. We've looked at square roots primarily because that's where the restriction is. But that could also be with 4th roots or 6th roots. But if you ever see an odd root, right? And again, that could be hidden, right? It could be t minus 1 to the 1/3. There's that root hidden. Then, unless it's in the denominator where zeros are still not allowed, the domain is no restriction. So d sub h is going to be all real numbers, or in interval notation, it'll be t epsilon negative infinity to infinity, right? Variables under odd roots in general are okay bueno, unless they're in the denominator, okay? If this were flipped, let's look at this, h, I, j, k. Let's do k of t. If this were flipped, 2 square root of 3 all over the cube root of t minus 1, now is the domain still all real numbers? No, the radical doesn't have any restrictions now, but we do have a denominator with the variable. So this still can equal 0. And if we cube both sides, we raise a green flag in this case. T can equal 1, and then we plug it back in to see if it's extraneous. 1 minus 1 is 0. The cube root of 0 is 0. It does cause a 0, so I'm not going to write it formally, but that would be the only domain restriction. Okay? And it's not because it's under a cube root. It's because it's in the denominator. Got it? 2 things. That's all we're doing. 2 things. All right. Any questions on number 6? As easy as it sometimes can be, sometimes we need to roll up our sleeves and apply a little elbow grease, almost as if we were working at Gana's Auto Shop, right?
So this means all real numbers if there's
I'm just curious, Brady, why you didn't ask a question about A when we were on A.
I'm just trying to reaffirm it for myself.
Okay, as long as you weren't doing something else, like looking at a comic strip.
I'm still just trying to recap.
That's fine, that's fine. But I still see you smirking over there and switching screens before I can get over there. So don't do that. Stay focused. What was your question now on A?
So a number in a square root over a fractional or fraction. I can't speak. Would equal in all real numbers.
Can anyone answer that question? Yeah, what was it? Can you try to frame the question a little bit? I really don't know.
I'll just look back to
No. I really want to answer your question. I'm not sure what you're asking.
I was asking how it got to be the all real numbers. Like how exactly.
Oh, okay. Well, we're trying to avoid 2 things, right, Brady? And everybody, we're trying to avoid division by 0. Let's do that first. Do you have any denominators in this equation, in this function? There's 1 denominator.
Yes.
It's right there. But it's a constant. It's a 3. Is 3 ever 0? No, not even at a masquerade party. So it passes that test. We clear that hurdle. The next thing is, do we have any square roots, 4th roots, even roots? Yes, we do. There's 1 right there. We don't want negatives underneath there. What's underneath there? A 3. Is 3 ever negative? No, not even at Halloween, right? Because the clothes don't make the man, and the man doesn't make the clothes. I'm having a little bit of deja vu. So it clears that hurdle. If we clear those 2 hurdles, or it passed those 2 objective tests, then guess what the domain is for now? All real numbers. There will be a time where we look at piecewise functions. There will be a time when we look at log functions, and those are different. But we're not going to see those now. I want you to master those 2 things. Does that answer your question, Brady?
Yes.
Okay. Please pay attention the entire time, not just when it's convenient, okay? All right, y'all have a great, fantastic rest of the day. Tomorrow we're going to look at just a couple of these. Okay, we'll look at maybe these 4, and then we'll talk about the test. Remember, the test will not have holes or vertical asymptotes on it. So if you're done with the worksheet, it's not due Thursday, work on some of those practice tests. Okay, au revoir, bye-bye. Bye-bye.